This is Zeno of Elea, an ancient Greek philosopher famous for inventing a number of paradoxes, arguments that seem logical but whose conclusion is absurd or contradictory. For more than 2,000 years, Zeno's mind-bending riddles have inspired mathematicians and philosophers to better understand the nature of infinity. One of the best known of Zeno's problems is called the Dichotomy paradox, which means the paradox of cutting in two in ancient Greek. It goes something like this. After a long day of sitting around thinking, Zeno decides to walk from his house to the park. The fresh air clears his mind and helps him think better. In order to get to the park, he first has to get halfway to the park. This portion of his journey takes some finite amount of time. Once he gets to the halfway point, he needs to walk half the remaining distance. Again, this takes a finite amount of time. Once he gets there, he still needs to walk half the distance that's left, which takes another finite amount of time. This happens again and again and again. You can see that we can keep going like this forever, dividing whatever distance is left into smaller and smaller pieces, each of which takes some finite time to traverse. So, how long does it take Zeno to get to the park? Well, to find out, we need to add the times of each of the pieces of the journey. The problem is, there are infinitely many of these finite-sized pieces. So, shouldn't the total time be infinity? This argument, by the way, is completely general. It says that travelling from any location to any other location should take an infinite amount of time. In other words, it says that all motion is impossible. This conclusion is clearly absurd, but where's the flaw in the logic? To resolve the paradox, it helps to turn the story into a math problem. Let's suppose that Zeno's house is 1 mile from the park, and that Zeno walks at 1 mile per hour. Common sense tells us that the time for the journey should be 1 hour. But let's look at things from Zeno's point of view and divide up the journey into pieces. The first half of the journey takes half an hour. The next part takes 1/4 of an hour. The third part takes 1/8 of an hour, and so on. Summing up all these times, we get a series that looks like this. Now, Zeno might say, since there are infinitely many terms on the right-hand side of the equation, and each individual term is finite, the sum should equal infinity, right? This is the problem with Zeno's argument. As mathematicians have since realized, it is possible to add up infinitely many finite-sized terms and still get a finite answer. How, you ask? Well, let's think of it this way. Let's start with a square that has area 1 unit. Now let's chop the square in half, and then chop the remaining half in half, and so on. While we're doing this, let's keep track of the areas of the pieces. The first slice makes 2 parts, each with an area of 1/2. The next slice divides one of those halves in half, and so on. But no matter how many times we slice up the boxes, the total area is still the sum of the areas of all the pieces. Now you can see why we chose this particular way of cutting up the square. We've obtained the same infinite series as we had for the time of Zeno's journey. As we construct more and more blue pieces, to use the math jargon, as we take the limit as n tends to infinity, the entire square becomes covered with blue. But the area of the square is just 1 unit, and so the infinite sum must equal 1. Going back to Zeno's journey, we can now see how the paradox is resolved. Not only does the infinite series sum to a finite answer, but that finite answer is the same one that common sense tells us is true. Zeno's journey takes 1 hour.